Step 1. Preparing the probe. After screwing off the probe, rinse the tip of the probe with DI water. Then, pat off excess water. Step 2. Calibrating the probe. In order to calibrate, we need to use buffers. What are buffers? Buffers react with acids or bases, but resist large changes in pH. They can consist of a weak acid and its conjugate base, or a weak base and its conjugate acid. Today, we will use two buffers to calibrate. Buffer 1 with a pH of 7, and buffer 2 with a pH of 4. Let's start with buffer 1.
Place the probe in buffer 1. Then select Sensors, then Calibration, and select your probe. Click Calibrate Now and enter the known pH of the buffer. In this case, it is 7. Now it is calibrated. Let's do buffer 2. Repeat the previous steps for buffer 2. Now that we are calibrated, let's find the pH of unknown samples. Step 3. Finding the pH of unknown samples. This is apple juice. We found it to have a pH of 3.10. This is hydrochloric acid. We found it to have a pH of 0.36. This is orange juice. We found it to have a pH of 3.35. Here's our data table with other samples. Weak versus strong acids in equilibrium. Hydrochloric acid and acetic acid. Hydrochloric acid has a pH of 0.36 and acetic acid has a pH of 0.34 as we found. However, they ionize differently in water. Hydrochloric acid is a strong acid. It completely ionizes in an aqueous solution. This means that it breaks apart completely into chlorine ions and hydrogen ions. Acetic acid is a weak acid. It does not completely ionize in an aqueous solution. This means that while a few molecules may break apart, a lot of them don't. How does this affect equilibrium? Weak acids dissociate partially at equilibrium, meaning that a higher percentage of the weak acid remains unbroken, allowing for a more balanced equilibrium between reactants and products. Strong acids completely disassociate, making the percentage of unbroken molecules much lower, making a less balanced equilibrium. Screw the pH probe back into the liquid and give to the TA for storage. Make sure to wipe the lab bench. Wash your hands after handling acids and bases, and wash glassware with lots of